Hello, am I audible?
Yes, ma'am.
Okay. A warm good evening to all. On behalf of IEEE PES Kerala chapter, I welcome you all to today's session on smartphone controlled robots, organized as a part of workshop series held in association with STEM Ed mentoring cum project development program focused on school students and teachers intending to help children develop their skill set in science, technology, engineering, and mathematics. In this third session of workshop series, aimed at providing the students with necessary skills required for project implementation, we have Mr. Anish M S as our resource person. He is the Global Relations Coordinator of IEEE PES YP Kerala. Now, let me invite Ms. Navya of MES College of Engineering who will comment it. Navya, please.
Thank you, Bhagya, and good evening, all. Hope you all are doing well. It's my privilege to address you all today. So, firstly, with immense pleasure, I welcome our esteemed resource person for today's session, Engineer Anish M S, the Global Relation Coordinator of IEEE PES YP Kerala. And now, I welcome all the students and teachers in this session. So, without making a delay, I welcome Engineer Anish M S, sir, to take the session. Sir, over to you, sir.
Yeah, good afternoon to all. Thank you, Bhagya and Navya, for the introduction. Hope I am audible to you.
Yes, sir,
Yes,
you're
yes.
audible.
Yeah, okay. So in today's session, I hope you enjoyed the last two sessions and you might be familiar with the basics of Ordno now. And in today's session, we'll be demonstrating a project. It's just how to apply these things you had already studied to build a robot. I'm also planning to complete within 1.5 hours, but let's see. So straight away we can jump onto the session. Just confirm whether you're able to see my screen now. Is it visible now?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So smartphone controlled robot. So this entire session is divided into three different sessions. One will be the familiarization, then just the hands-on, and then how to build the entire robot. That's it. So let's familiarize. What is a robot? So this is the first question which I would like to throw on you. What is a robot? Anyone can answer. Will not take much time, but anyone can answer. What is a robot? In your opinion,
A
what is a robot?
automatic machine. Automatic
Automatic
machine.
machine. Yeah. Anyone else?
It can move.
Okay. Do you know which robot this is?
Asimo.
Its name is already mentioned here. It's Asimo. Do you know which company produced Asimo? It's produced by Honda. Okay. So what is a robot? A robot is a machine which is capable of carrying out complex series of actions automatically, especially one programmable by a computer. So that is what we are doing. Any machine which is capable of carrying complex series of activities automatically by giving a certain program to this device. So that is what we had studied in the last two lectures. First one was what is the basics of Arduino, that is a programmable device, a programmable controller, and the next session you studied, I hope you studied, Hari had explained how to program a Arduino board. And now we are going to combine all this knowledge to build a robot. Okay. So these are the parts which are required for our project, today's project. We need an Arduino Uno. We need a Bluetooth module, HC06 Bluetooth module. Then we need a geared DC motor. I had also explained what is a geared DC motor in the last lecture, and a motor driver. I'll be explaining all those things in this session, and I'll explain how to combine all those things to build a robot. So you are already familiar with Arduino board, so I am not going to explain further. You know, Arduino board has digital pins over here, analog pins over here, and the power section over here. And this is the chip. This is the connection to the PC. This is the power connection. This is the reset switch. Yeah, that's it. almost everything done. And these are the indicator LEDs, TX transmission, reception indication LEDs, everything. Okay, and these are the features, technical features of Arduino Uno, which are not much necessary for you for doing the program and building the robot. And now the software, you're already familiar with the software. I'll just show the software. Yeah, this was the Arduino IDE software, and what you need to do while connecting an Arduino board is, first you can directly plug in the Arduino board. This is our Arduino board. We had connected the wire, and this cable can be connected to the USB port. And once we connect to the USB port, we have to configure, okay, which Arduino board you are using. Currently, I'm using Arduino Uno, and we can go to the tools. And in the board section, you can see, are you able to see my screen?
Yes, sir.
Yes.
Okay. So you're already familiar. I hope that you're already familiar with this software. I had explained all those things. And now how to configure the board. Okay, once you connected the board, you can go to the tools, and in the board section, you can select Arduino Uno. Okay, which board you are using. If you're using an Arduino Nano, you can select this Nano. If you're using Arduino Mega, you can use this Mega. If you're not aware which Arduino you are using, you can go to the ports, and there it will be showing that which Arduino is being connected. You have to select this port also. Okay, so in my computer, it's COM5, so I am selecting COM5. So in COM5, I have Arduino Uno, and in the board section, I had selected Arduino Uno. That's it. Okay. So that's it. Everything is configured. Now, if you click on the upload button, the program will be uploaded. Any program? Sorry.
So can you zoom? The code is not visible.
Oh, okay. 1 second. Yeah, this is just some other program. It's for the ultrasonic sensor, which is not required for you. Your program will be shown in the coming slides. Yeah. Okay, and this is the serial monitor, which I had already mentioned in the first session. If you click on the serial monitor, you will be shown this window, and if some sensor values are coming, then it will be shown here. Okay, in this section. Yeah, that's it about the software. And then we require a geared DC motor. You might be familiar with the geared DC motor. These are the motors which you find in the toy cars, dolls, and everything. So here, these are the specifications of the geared DC motor. I'll share the PPT with you so that you can take this thing.
Older ones we didn't get the first 2 sessions.
You didn't get? Okay, you get the recording, right?
Sir, last session it was half recording only.
3 hours it was, but we got 1.5 only.
Okay, I was not aware about that thing. So I'll ask them to share the entire presentation. So these are the specifications. If you're planning to buy, you can take these specifications, but just go and tell the shop that you need geared DC motor. They will be showing different varieties of geared DC motor. You can select anything. Okay, and these are the motor drivers. So I'll explain the purpose of the motor driver. So imagine you take a geared DC motor and you just connect the battery to it. It will be rotating. Okay, but in a robot, we need to move forward, move backward, right, left. Each and every movement should be possible. For that, we need to, but we cannot put each and every motor for each control. In order for moving forward, we can put one motor, and moving backward another motor. It's not possible. So we only have 2 motors, and these 2 motors have
change the direction.
Do all the, yeah, change the direction. It should go forward. It should move backward. It should go right. It should go left, etc., etc. Okay. For that, we have a controller or a driver. Okay, so the purpose of this driver is to change the direction of this, the rotation of this motor. So if each motor is rotating backward, the robot will be moving forward. And if it is in the other direction, it will be moving backward. And one is rotating forward and another is rotating backward. It will be moving in right direction, and then the other way in the left direction. That you can configure by trial and error method. For that purpose, we will be using this motor driver. The name of this motor driver is L293D driver
Each
module.
motor
L29.
separate.
I didn't get you.
Each motor separate driver or one driver for entire?
No, no, one driver. I'll explain. Okay, one driver for two motors. Okay, we'll be using two motors, and for two motors, we'll be having one driver. And these are the standard structures of the L293 module, 93D modules that can be bought from some electronic shops. So we have the following pins. I'll explain the relevant ones. This enable 1 and enable 2 will not be used for us. So we have this 5 volt. Can you see the 5 volt one? It's visible, right?
Yes, sir.
Yes.
Yeah. We have a 5 volt and a ground. This 5 volt and ground will be connected to the 5 volt and ground of the Arduino, which I had already shown. These things, this 5 volt here and ground here, you can connect the 5 volt and ground of that this thing to the 5 volt and ground of the Arduino. And we have the 12 volt here. This 12 volt is for driving the motor. Okay, 5 volt is for this IC, powering the IC, and this 12 volt is for powering the motor. Okay, and now we have two connections. There is in 1, in 2, in 3, and in 4. Okay, these will be connected to the digital pins of Arduino. Any 4 pins of this thing. Okay, any 4 pins can be used, and these are the pins which control the direction of the motor. Okay, you can either put like in 1 high and in 2 low. Okay, this pin is put high and this pin is put low. Then one motor. This is the first motor, and here we will be connecting the second motor. Okay, so this first motor will be running in a particular direction if you put H, that is high in the first in 1 and low in the in 2. And if I reverse direction, if I put a low here and a high here, then it will be rotating in the, if it is rotating like this in the first direction, then it will be rotating in the reverse direction. Okay, simple. And this can be done through the programming. Same is the case for the second motor also. You can you have in 3 and in 4, and in 3 I put high and low, then it will be rotating in one direction, and if I reverse this and it will be rotating in the other direction. So simple. And these reversing of the direction, reversing of the high and low, everything is done through the program. So it's very easy.
How
and that is the purpose of the motor
driver.
driver. Yeah, I'll explain. Don't worry. Okay, these are the connection to the Arduino board. Okay, these are for the Arduino board, and here is the connection for the motor. Okay, the motor will be having 2 wires, right?
Connected.
Sorry.
Sir, where in can be connected, in Arduino or in motor?
In Arduino. These entire connections are going to the Arduino, and here this 12 volt will be to the battery. You can connect a separate battery, 12 volt battery for running the motor. Okay, 12 volt will be for the battery. I'll explain the connection diagram. Don't get too excited. So I'll explain the entire connection diagram. This is just the introduction. Okay. So the 12 volt will be connected to the battery, and these two slots are for the motors. Okay. So I'll take one wire connect to the motor, and second wire will be connected to this point. So one motor is completely connected, and now for the second motor also same thing. Okay, so imagine this is our motor. We have a motor like this. One wire will be coming out from here, one wire will be coming out from here. One will be connected to this slot, and another will be connected to this slot. Okay, there will be opening. You can see in the left side there will be opening here. You can unscrew this thing and connect the wires here. Okay, same in the other case also. These are just two models. This is the most common model. This is a little bit uncommon. That's it. Okay, and another motor can also be connected in the similar way. Simple. And the connection diagram, there is a proper connection diagram for the entire circuit. I'll be explaining it later. So this is the motor driver, the purpose of the motor driver, and the connection, simple connections of the motor driver. Okay. and this is the name of the motor driver. There are lots of other drivers too, but this one is the most commonly used one, L293D, and you have also L298. Yeah. And how the direction is being changed, in this. This is a little bit complicated. You don't you need not to bother about all those things. These are the diodes, MOSFETs, all those things. These are the just consider these as switches. Okay, these are just simple switches. So yeah, this is our motor. Okay, I had connected it in such a way that we provide the 12 volt here and the ground here. For example, if you have a battery, I connect the battery like this. Okay, so this is our 12 volt battery. So this is our connection, and the motor is connected. It's like a bridge. It's like an H, right? It's like an H.
Sir, class എടുക്കുമ്പോൾ കുറച്ച് മലയാളം കൂടെ പറയുകയാണെങ്കിൽ നന്നാവുമായിരുന്നു.
Yeah, I had already mentioned in the first session itself. I would like to introduce some Malayalam into the session, but most of the people told that they only understand English. They don't understand Malayalam. But what can I do? Is there anyone who doesn't understand Malayalam?
Some are there.
Or
many are there.
how much?
Majority.
Yeah, can you just post it in the comment section who are not at all able to understand Malayalam?
So geared DC motor and normal, what is the difference?
Yeah, wait. 1, 2, 3, 4, 5. Yeah, there is a lot. So that's why I'm not continuing in Malayalam. I'll be continuing in English. And if you have any specific doubt, if you have any the one who asked, if you have any specific doubt, just ask. I'll explain that in Malayalam. Okay. നിങ്ങൾക്ക് സ്പെസിഫിക് ആയിട്ട് എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടെന്നുണ്ടെങ്കിൽ, അതായത് ഇന്ന കാര്യം മനസ്സിലായില്ല എന്നുണ്ടെങ്കിൽ നിങ്ങൾക്ക് ചോദിക്കാം. ഇന്നത് മനസ്സിലായില്ല, അതൊന്ന് മലയാളത്തിൽ എക്സ്പ്ലെയിൻ ചെയ്യാവോ എന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ ഞാനത് മലയാളത്തിൽ എക്സ്പ്ലെയിൻ ചെയ്യാം. ഓക്കെ, നോ പ്രോബ്ലം. Am I clear to you?
Yes, sir.
Yes.
Yeah. Now, what was your doubt? Yes. Someone was asking, right? Okay.
I don't think so.
Yeah. Okay. So I was explaining the H bridge, how the direction of the motor getting changed. So we had connected the battery here. It's not a capacitor, it's a battery. Okay. We had connected the 12 volt battery here. And for example, normally we will connect the battery like this, right? I have a motor here. I connected the battery, and the motor will be rotating in a direction. Okay. If I connect the battery like this, if I connect the battery in the opposite direction, okay, the positive terminal was connected here and the negative terminal connected here, it will be rotating in a particular direction. And if I reverse the direction, okay, if the positive terminal is connected to the negative and negative terminal is connected to the positive, then initially it was rotating like this, but now it will be rotating in the opposite direction.
Reversed.
Right. Reverse direction. So this is the simple mechanism, but we need to rotate this particular motor in both direction. In some scenario, if it is moving forward, it should rotate in particular direction, and if it is moving backward, it should rotate in the other direction. So one motor should rotate in both the direction, but we cannot all the time we cannot change the direction of the battery. We cannot remove the battery, reverse the connection, and then again put the battery. It's not practical. So what we are going to do is we are going to use the switches. Okay. So
how many motors are we using?
We are using 2 motors. Okay, 2 H bridge. This is the first motor. Okay, and these are the connection for the first motor. And for example, this is I had connected the battery like this. Here is the positive, and here is the negative. Okay, so initially I closed this switch and this switch. Okay. Through the program, I am closing. I can control the motor. I had already mentioned that I can control the motor driver using the program, and through the program, I had closed these two switches, switch S1 and S4. Now you can see the positive terminal is connected to the positive of the battery, right? Because this connection is not there, this connection is not there. Positive terminal is connected to the positive of the battery, positive of the motor, and the negative terminal is connected to the
Negative.
negative of the battery, right? Then it will be rotating in particular direction, say this direction. And now, okay, I need to rotate in the opposite direction. What I do is that through the program, I remove this switch and remove this switch. I opened these two switches and I closed these two switches, okay, the opposite switches.
S2, S3.
What happens now is that this direction is changed, right? The positive terminal is now connected not this way, but this way to the negative terminal. Initially, it was connected to the positive terminal. Now it's connected to the negative terminal. And the negative terminal is now connected to the positive terminal. Now the direction is changed. Initially, it was positive, negative. Now it's negative, positive. So the direction will be in the opposite direction. Rotation of the motor will be in the opposite direction. Simple. This is the working. And for these, replacing these switches, we will be using MOSFETs. And for the controlling, we will be using this thing, diodes. Okay, simple, but you need not to worry about the MOSFETs, diodes, all those things. These are the electronics involved, but you can control the entire thing using the program. Okay, is it clear for you?
Yes, sir.
So why does the path of the electricity change on its own?
Why does the
Path of the electricity change on its own on one side? Why is it going to the other side?
Why is it going to the other side? Yes, the answer is very simple. Electricity will only flow through the continuous paths. Okay. For example, if this thing is closed and this thing is closed, electricity has only one way to go through these. Okay, it cannot go through here because it's already open. It will come here and there is no other path. Okay, it will only go through a closed path.
Actually, it is going both ways, but this way only it's fully going.
No, it will not be going this way because you need a potential for the flow. Okay, you which standard you are from?
10th.
10th. Okay, you might have already studied, right? The potential difference and all. If you it will be flowing from the higher potential to lower potential. So here there is no potential. Okay, then there will not be any flow. So if the path is just completed, then it will be having a higher potential here and it will be having a lower potential here and it will be flowing like this. But if there is a disconnection in between, it will not be flowing at all. Okay, and if I put a connection like this, okay, this is already connected, and if I put a connection like this, then it will start flowing from here to here. Okay. So that is basic electrical engineering, basic electrical theories that you will study in 10th, 11th, 12th, etc. Electrostatics and all, yeah. And this is the H bridge. Any other doubts?
No, sir.
No, sir.
Yeah. Okay,
No, sir.
okay. We can go forward. Now, much more complicated module. It's a Bluetooth module. You might be familiar with Bluetooth. You will be using Bluetooth headphones, Bluetooth in your smartphones. Everything is now earlier connected with Bluetooth. Now it's changed to Wi-Fi, but yeah, we can go with the older version. So HC06 is a Bluetooth module. HC06 or HC05, anything is fine. Is a Bluetooth module which can be connected to the Arduino board. Okay, and while if we connect this Bluetooth module to the Arduino board, then you can control different Bluetooth enabled devices using the Arduino board. You can just program the Arduino board accordingly, and these module, this HC06 module, will be controlling the Bluetooth enabled devices. For example, Alexa, and some other Bluetooth enabled devices like your headset, the Bluetooth enabled light, etc. Yeah, it can be controlled using Arduino board. And here we will be controlling this entire robot using our smartphone. Okay, So we are communicating with this device, with our robot using this HC06 Bluetooth module. Okay. So the communication between your phone and this robot is enabled using this HC06 Bluetooth module. And it has the following parts. This is HC06. This one is HC06. And HC05 is also similar, but it doesn't have these two pins. Okay, these two pins are not at all necessary for us. We just need these 4 pins. Okay, these 4 pins are required for us. And I'll explain these pins. This VCC and ground is as usual connected to the 5 volt and ground. This is connected to the 5 volt of Arduino, and this ground is connected to the ground of Arduino. Okay, as I had already mentioned in case of it, the L293D module, the driver module, similar is the case of this HC06 module also. VCC will be connected to the 5 volt and ground will be connected to the ground. Do you have any confusion in that thing?
No, sir.
No, sir.
Anyone? There should be a confusion. That's why I asked. If you're following tightly, then there should be a confusion.
There are the driver we already connected to 5 volt. So another 5 volt is
Exactly.
also there, right?
So how this Bluetooth
Driver we had already connected to the 5 volt. Then how are we going to connect? Because we already
Two
have
5
this
volt
5
is
volt
there?
here. No, only one 5 volt is there. But
Then
should
we
we
can
do?
tell another pin as 5 volt or something.
We can either
can
set
use
one
the
pin as
board.
5 volt, but not necessary. You can use this a breadboard. A breadboard will be having a lot of connections like this, parallel connections. This will be the same. You can connect this 5 volt to this pin so that there will be a lot of
This row.
slots like this: 1 slot, 2nd slot, 3rd slot, like that. I had already showed the breadboard right in the last presentation. So you can connect one wire to this breadboard's one row, and this entire row will be 5 volt. Okay, so now you can connect this pin to the driver, this to the Bluetooth module, and if you want some extra LED or something, you can connect like this. So this is a possibility. And either otherwise you can
The
use this
board should be
3.3 volt
connected to
also,
ground now.
because Bluetooth module will
So Abhinav
work
was
in
asking
3.3 volts.
something.
Sorry?
So the board must be connected with 5 volt and ground now.
Yes. Ground is, we have 3 possibilities of ground, right? We have 1 ground here, 2 ground here, and 3 ground here. So ground is readily available, but 5 volt is not much available, right? And you can do this thing in the breadboard. You can select 1 row for 5 volt and select 1 row for ground. You can fix it. 5 volt is connected to here and 1 ground is connected to here. Then the connection will be much more easier for you, because each and every module which you will be using will be having a 5 volt and ground. A VCC and ground will be there. You can directly take a wire from VCC to this row and take a wire from the ground to this row. Okay, easy.
So connecting to this pins is removing the screw that way, right?
Sorry, connecting to this pin.
We're always telling connect to the pin. We are connecting by removing this, unscrewing it, and like that, right?
No. We have something called what? 1 second. I'll show you. We have something called jumper wires. Jumper wires. Yeah. Can you see this thing?
Yes, sir.
Yes,
Yeah,
sir.
these are the jumbo wires. It has this connection pins right here. Okay, you can directly just put it in, directly plug in. Easy. You don't need to unscrew like that, because all the connection to the Arduino boards and this drivers will be through these jumbo wires. These are male to male jumbo wires, and you will be having like male to female jumbo wires, in which, yeah, this one. These are female to female jumbo wires. You have many options, but you can select accordingly. Yeah, these are female to female jumbo wires. So you have a male pin here. For example, this pin can be connected to this male to female pins. Okay, we'll be using this male to male pins because both our connections. See, these are the female pins. Okay, you can just plug in the male pin here. See, these are the holes in which you can plug in the male pins. And here it's male port, so you can use the female ports. Okay, it will be having holes and you can directly plug in here. So if you're using a male to female jumper wire, I'll show you male to female jumper wire, then you can use the connections easily. Male to female. Yeah, these are the male
Male
to
is a
female
straight
jumper
one
wire.
and female is which can hold the pin.
Yeah, if you have a projection out, then it will be male, and if you doesn't have a projection out, then it will be female. Okay. Don't bother about the language, it will be showing in German. Just focus on the pictures. Okay. Yeah, this is the male port where you have a projection out, and here is the female port where you have a hole. Okay, so this male port can be connected to the Arduino board, and this female port can be connected to your this motor driver. Okay, simple. So you need not to worry about the connections and all. You can buy these things. It's quite cheap. It won't be this costly there. It's showing the 2.8 euros, but it won't be that costly there. You can get it for like two rupees per piece or something like that.
Okay, sir.
Yeah. Okay. Where were we? Yeah, we were here. Yes. So here also we have this male port. You can use the male to female connection. Connect the female port here and connect the male port to the Arduino board. Okay, so I hope you understand the VCC and ground. It will be connected to the 5 volt and the ground, and then we have this TXD and RXD. Okay, this is simply TXD means transmitter and RXD means receiver. So in order to establish a serial communication between this Arduino board and our Bluetooth module, we need a serial communication. A serial channel should be established between the Arduino board and the Bluetooth module. Okay, so this communication is enabled by using these two ports. TXD means transmitter. If you are sending a data, we are sending a data to this Bluetooth module. Okay, through our phone, we are sending a data to the Bluetooth module. This Bluetooth module has to send this data to the Arduino board. Okay, for that we will be using this transmitter. We will be receiving a signal. We will be transmitting it through this TXD port to the Arduino board, and the Arduino board will be receiving it through the receiver port. Okay, Arduino board has a receiver port. You can see the RX here. Okay, this is the receiver port, and Arduino board also have a transmitter port because we need to communicate. We need to send the signals back also, right? So the Arduino board will be sending a signal through this transmitter port, and this transmitter port will be connected to the receiver port, the RXD of this Bluetooth module. Okay, the connections is already mentioned in the connection diagram, so you do not to worry about. You'll be a little bit confused about the TXD and RXD. So just remember, the TXD of this Bluetooth module will be connected to the RX of Arduino board, and RXD of the Bluetooth module will be connected to the TX of Arduino board.
Opposite
Okay?
always.
Opposite always, because what being transmitted from the Bluetooth module should be received by the Arduino board, and what being transmitted by the Bluetooth by the Arduino board should be received by the Bluetooth module. So that's why we are connecting.
Example for transmitting from Bluetooth module is like go forward, go back, like that.
Exactly.
This type of signals will be good.
Because if we need to control using the mobile phone, we are pressing the forward button. The forward signal will be received wirelessly. This is the antenna here, wirelessly to the Bluetooth module, and Bluetooth module received the forward signal, and it need to send this signal. Okay, the forward message to the Arduino board. It will be a received signal here, and it will be transmitted to the Arduino board. Okay, and the Arduino board need to send something back to the Bluetooth module. It can be done through the other pin. Simple.
What will the Arduino send?
Arduino can, like for example, if you doing some reverse communication. For example, if you're using the Arduino board as a remote for the Bluetooth, then you can use the receiver pin. So serial communication means transmission and reception. So both you need the both thing. For example, there will be interrupts. Interrupts are called what? How can I explain an interrupt? For example, a particular signal is being sent, but Arduino is telling that you need to stop receiving this signal because I need to do something. Okay. Arduino is busy doing something and you need to stop receiving the signal. That message should be sent from the Arduino board to the Bluetooth module, right? In order to tell the Bluetooth module that you need to stop receiving the signals. It is a transmitted signal from the Arduino and a received signal by the Bluetooth module. These are called interrupts. Interrupts are made for like stopping a device from doing something. Okay. These are like little bit complicated details of these modules. We don't need all those things. We just need to do the connections, and rest will be taken care by the software. Yes.
In between, you were selling something that the VCC can be connected to 3.3 volt.
Yes, VCC can be connected to 3.3 volt if it is compatible. Some Bluetooth, you see, 3.3 volt is compatible with this thing, but some will not be compatible with 3.3 volt. And it's better to connect with the 5 volt because it will be taking like much more power. So if you could connect to the 5 volt, then it's okay. If you couldn't connect,
it's efficient, isn't it, sir?
Sorry.
It's efficient with 5 volt.
Yeah, it will be efficient with the 5 volt, and it will be 3.3 volt will be sufficient also. Yes. If you don't have any options, if you don't have any this breadboard or something, you can connect to this 3.3 volt. Because our L293D IC will not be working with the 3.3 volt, but this will be compatible with 3.3 volts. Okay, these are the technical specifications. See, operating voltage is from 3.3 volt to 6 volts. So you can either use 3.3 volt up to 6 volts. Beyond this 6 volts, then the module will be damaged. So we should not apply more than 6 volts. These are the technical specifications. And these were the familiarization. These were the components required for our project, and these were the technical components like the electronics involved. And we need some physical components like the tires, the chassis of the body, the caster wheels, and all those things you can directly get with the kits. If you go for an electronic shop and ask for the robotic kit, then they will provide all those things, the non-technical things, the physical things. And robotic basics, the hands-on, it should have been a hands-on if you have all those devices, but unfortunately you doesn't have all those devices. So I'll explain how these devices will be connected.
So before that, one doubt.
Yeah.
The geared DC motor, what is it? I didn't get. The geared, what is the difference between normal DC motor?
What is the difference between normal DC motor and the geared DC motor? Okay. So normal DC motor will be having only this bottom section, okay, the DC motor section. But here we have a gear. For example, our do you know what is the purpose of the gear in a car?
For different speeds.
For different speeds, no. It's actually not for different speeds. It's for different torque. Okay, something called torque is there. How to explain torque? The circular angular force is called torque. Okay, angular force is called torque. Yes, Abhinav.
Sir, in the engine it is there, I think so. The top of the engine it
Where?
is CC and all is counted in that place.
I didn't get you.
Sir, gears are in gear. The length of or the power of gear is measured with the CC.
Okay, it's mentioned in the CC. Yeah, I was not asking about what is mentioned. What is the purpose actually? Okay, the underlying purpose of the gear is to provide different torque. For example, if you are moving in a straight path, okay, you can go in the 6th gear because 6th gear will have very less torque. Okay, for example, it will be having less torque but more speed. Okay, more speed or more velocity. if you are moving in the sixth gear. So if you are climbing an uphill, okay, if you're climbing an uphill, then you need more power to climb this hill, because if you're moving in a straight line, you doesn't need more power, right? That's why if you're putting in the sixth gear, it will be moving faster because it doesn't have much torque. If you're climbing a hill, then we will be down, putting the gear down, right? If we will be changing from 6 to 5, 5 to 4, 4 to 3, like that. And if you're climbing a steep uphill, we will recommend, right, we should put in the first gear and then climb. Why? Because first gear will be having highest torque. If it is in 1, then the torque will be most and the speed will be very less. Okay, velocity will be low and the torque will be high. So in order to provide this variation, we are putting a gear. If it doesn't have this gear, if we only have this DC motor, then we can only control the velocity. Okay, we cannot control the torque. We cannot provide differential power to this tires. So for that purpose, we are using this geared motor, because once we construct this, I'll show.
Torque is like power, right?
Torque is angular power. Okay, if you are, for example, if you are pushing something in a straight line, it is power. But if you are if you are providing a power to a rotating device, then it is called torque. Okay, so this is a robot, and you can hear the sound, right? This is the sound of gears rotating. Okay, so it has a weight of maybe more than 300 grams. Okay, so for example, a 500 gram, we can say that it weight around 500 grams or 1 kg. So our normal DC motor will not be able to handle this much amount of weight. For example, if you have a toy car, okay, if you put some pressure in the top of the toy car, will it move?
No.
No. അതായത് നിങ്ങൾ ഒരു കളിക്കുന്ന ടോയ് കാർ എടുത്തിട്ട് അത് നിങ്ങൾ റിമോട്ട് വെച്ച് കൺട്രോൾ ചെയ്യാണ്, ആൻഡ് യു ആർ പുട്ടിംഗ് സം പ്രഷർ ഓൺ ദി ടോപ്പ്. യു ആർ ജസ്റ്റ് അപ്ലൈയിങ് എ പ്രഷർ ലൈക്ക് ദിസ്, ഓർ യു ആർ പുട്ടിംഗ് എ വെയിറ്റ് ഓൺ ദി ടോപ്പ് ഓഫ് ദിസ് തിങ്. It will not move because it doesn't have the power to move this motor. ഈ മോട്ടർ കറക്കാനുള്ള പവർ അതിനില്ല. Okay, so if you put some gears, what it will do is that it will reduce the speed and increase the torque. ഈ സ്പീഡ് റെഡ്യൂസ് ചെയ്തുകൊണ്ട് ടോർക്ക് ഇൻക്രീസ് ചെയ്യും. ഓക്കെ, സോ ഇഫ് യു പുട്ട് സം പ്രഷർ ഓൾസോ, ഇറ്റ് വിൽ ഹാവ് ദി പവർ ടു മൂവ് ഫോർവേഡ് എലോങ് വിത്ത് ദാറ്റ് പ്രഷർ. നമ്മൾ കൊടുക്കുന്ന വെയിറ്റോടെ വെച്ചിട്ട് മൂവ് ചെയ്യാനുള്ള കപ്പാസിറ്റി ഈ ഗിയർ അതിന് കൊടുക്കും. ഓക്കെ, that's how the gears will be working. And if you want, I can show. I don't know whether time permits, so I will show what is inside a gear DC motor. I'll show. You have different options also. You have plastic gears, metal gears, gear DC motor. Yeah. Can you see this? So this is the cross section. So we have the motor right here. The motor will be this is the connection to the motor. The initial, where's my pen? Initial connection to the motor. We have a gear here. Then it will be connected to the another gear and small gear. Okay, so there is something called gear reduction and all, which you will be studying in mechanical engineering. It's a little bit complicated, but you need not to study about all those things now. But based on the number of teeth, okay, based on the number of teeth, the radius of this gears, the torque will be changing, and that's how we will be providing a different torque in this thing. That's how the speed is getting reduced and the torque is getting increased. Okay, you can search. These are the plastic geared ones.
So now what you said I didn't get last.
Yeah, you will not get, because it's pure mechanical engineering. Okay, if I start explaining all those things, then time will not permit, because there is something called gear reduction. Simply saying what, you have a bigger gear and a smaller gear. Okay, this bigger gear will be rotating in a particular speed, and you're connecting a second gear to this bigger gear, and it will be the second gear will be rotating in a particular speed. And based on the speed, if the speed is high, then the torque will be low. So the first gear will be rotating in a higher speed and lower torque, and second gear will be rotating in a lower speed and higher torque. And if you take the connection from this point, okay, yeah, 1 second. Okay, so this is the motor. For example, you can see the picture right here. This is the motor. If I take the connection from this point, it will be directly connected to the motor. So it will be the direct speed, the original speed of this motor. So I am connecting it to a gear here, then a larger gear here, then another gear here, and I am taking the connection from here. Okay, the wheel is connected here. So there is a gear reduction from this point to this point. Okay, and that's how the speed is changed from here to here.
So here, that really I cannot see which point you're telling.
Okay, I need a better picture, but I doesn't have a better picture.
That's okay, sir.
I'll search for a better picture. Yeah, this will be much more better, I think. Is it visible? This one?
Yes, sir.
Can you see the gear? Do you know what is a gear?
Circular thing with some.
Yes, sir.
Okay.
Friction is there.
If you doesn't know what is a gear, then there is no point in explaining all those things. So, yeah. Can you see this thing?
Yes, sir.
Yes, sir.
Yes, sir.
This thing is called gear. Okay. Okay. These are employed here for changing the speeds. And which one? Yeah. You can see a smaller gear here, right? The green one, which is connected to the directly connected to the motor.
Yes, sir.
Can you see? Okay. And when it will be rotating in the original speed of this DC motor, and this is connected to a larger gear here. Okay, so 10 rotations, maybe there is something called gear reduction. So for example, I am saying that this is a 10:1 gear. Okay, so 10 rotations in this smaller gear will be 1 rotation in this bigger gear. Let's say it's an example. Okay, 10 rotation in this smaller gear will be 1 rotation in this bigger gear. So what you can understand is that the DC motor will be rotating in a higher speed, and only after 10 rotation, 1 rotation will be completed in this bigger motor, this bigger gear. And I'm connecting a tire, our car tire, to this bigger gear. What will be happening? This thing will rotate 10 times, and 1 rotation of the tire will be completed, and another 10 times 1 rotation of the car will be completed. So this will be moving in a higher speed, but this will be moving in a slower speed. Okay.
Small one is faster.
What?
Small one is faster.
Small one is faster and bigger one is smaller. And I had connected my tire to the bigger one. What happens? The motor will be running in a higher speed, and the tire will be running in a slower speed. But since the tire is running in a slower speed, it will be having much more power. Okay, because of the gear reduction technology. Okay, gear technology which reduces the speed and increases the torque. Okay, if you spend a lot of time in that thing, we will not be able to move forward, because we are just
some idea got
the, yeah. The rest you can just Google, because it's pure mechanical engineering. What is gear reduction and all? But if you're taking engineering, you will study in the basic mechanical engineering. Okay, where were we? Yeah, we were here, right? Yeah, here someone asked about the gears. Okay, now we studied how to connect the Arduino, and just see the connection diagram. This connection diagram I had explained in the last lecture itself. So this is simple. The simple connection diagram, you can connect just the basic how to connect wires to the LED this Arduino board.
So that we did last class also.
I had LED here, I had connected the positive to here, I had connected the ground to here, and then I had done the programming. LED will be blinking. Okay, simple. This was the program. I had explained this program also, I hope. So I had set the 9th pin to output, and then I had inside the setup. 1 second, is it time?
It's going to be 1 hour only.
Yeah, it'll be one hour 15 minutes or something. Yeah, I had set the 9th pin to output, and I had inside the loop I had mentioned digital write 9 high, turn the LED on and wait for 1 second, delay 1000, and digital write 9 low, turn the LED off, wait for 1 second. This was a simple program. This was the analog program, and this is the connection of the HC05 Bluetooth module, which I promised that I will be showing you. You can see the VCC here. Are you able to see this thing? Or do I need to?
Yes.
Yes, sir.
Yeah, you can see the VCC right here.
Yes, sir. Yes, sir.
VCC is connected to the diagram for drawing tool where you can draw all those things.
Can you say again?
You can see this
Can you
is
say again? It is stuck.
This can you say again? It is stuck.
Is it visible now?
Yes, sir.
Yes.
Yes, sir.
Yes.
Yeah.
Yes, sir.
So you can see the VCC right here, right? VCC is the 5 volt. 5 volt is connected to where go up. Yeah, 5 volt is connected to the 5 volt of the Arduino. This is Arduino Nano, not the Mega of the Uno one, and the ground here is connected to the ground. The ground GND of this HC05, and you can see the TXD. TXD is the transmitter. This green one, okay, TXD is connected to the RXD of the
RX.
Arduino Nano, okay, RXD, and you can see the TXD of this Arduino. The yellow one is connected to the
RxD of Bluetooth module.
RXD of the Bluetooth module. This was the connection which I had already mentioned, and yeah, this is a picture. Yeah, so this is the connection diagram of the HC05 Bluetooth module, and you can download this app. Arduino, it's called Arduino Bluetooth. If you directly search on the Play Store, you will be finding this app, Arduino Bluetooth. It's like an Xbox controller. You can assign the values. For example, inside the settings of this app, you can assign the values for this thing. For example, for this arrow, I had assigned L. For this arrow, I had assigned B, like that. Okay, B, R, F. And we can program using these values. Okay, these variables. Yeah, these are simple values. It can be either a letter, a number, or something like that, and we can program using these letters. Okay, this is the Bluetooth testing program. Okay, simple, yeah, but complicated. Yes. So I'll explain the program once. Are you familiar with all those things? Because you had a programming class last lecture, right?
So, but serial begin that time?
Yes, sir.
Not sure.
Serial begin that time?
Yes, sir.
Not sure.
Serial begin was not there. Okay, serial begin is just.
So he
this
said,
is
but
9600
properly it was not.
is something called
He said, but properly.
Start the serial monitor.
Okay, I'll explain. See,
Start the serial monitor.
it's not for this serial monitor. It's for starting the serial communication. Okay. I had already mentioned that we are communicating with the computer and the Arduino board, right? So in order to start the serial communication between the computer and the Arduino board, we need a baud rate, something like at what speed this communication should be happening. Okay, so I had mentioned serial.begin 9600. It's called baud rate. Baud rate means bits per second. Okay. So you know that you'll say that this downloading speed is 100 Mbps, downloading speed is 2 Mbps, like that, right? That is megabits per second, megabytes per second. So 8 bits will be 1 byte. So it is specified in 9600 bits per second, 9600 bits per second. That is the transfer speed of the data between our computer and this Arduino board. Okay. So in order to establish this connection, we need to begin the serial communication. For that, we are using this command serial.begin 9600. Is it clear now?
So, but which value we need to
അതായത്
put?
നമ്മുടെ
How can we tell?
കമ്പ്യൂട്ടർ
value we need to put? How can we tell?
It's a default value for 9600. There are other default values are 1800 like that, but normally we will use
Last class
this
it was
default value. In order to
115200.
establish faster
115.
yeah, one that is also available, but normally we will use 9600 because if you increase the baud rate, the serial communication will be much more faster, but it will have some other problems. So normally we will use 9600. You can verify the other values also. Normally in Ordino Uno we'll be using 9600. If you're using Ordino Mega, then you can go for higher values. Okay, so what is this baud rate? Baud rate എന്ന് വെച്ച് കഴിഞ്ഞാൽ നമ്മുടെ ഓർഡിനോ ബോർഡും നമ്മുടെ കമ്പ്യൂട്ടറുമായിട്ട് കമ്മ്യൂണിക്കേറ്റ് ചെയ്യേണ്ട ആ ഡേറ്റയുടെ സ്പീഡ് കാണിക്കുന്നതാണ്. ഓക്കെ, 9600 ബിറ്റ്സ് പെർ സെക്കൻഡ് സ്പീഡിലായിരിക്കും ഇത് തമ്മിലുള്ള കമ്മ്യൂണിക്കേഷൻ ഡേറ്റ ഫ്ലോ ചെയ്യുന്നത്. And in order to begin this communication, we have to write this command serial.begin 9600. Okay, inside the setup, I had mentioned that this is one-time investment. Okay, so നമ്മൾ ഒരു പ്രാവശ്യം മാത്രം ഇത് മെൻഷൻ ചെയ്താൽ മതി. You need to mention only once in the program inside the setup that the serial communication should be established between this computer and the Ordino board. And now I had mentioned that pin mode 12 output. The 12th pin is set as output pin. Okay. And what else? Inside the loop, I am checking if serial dot available greater than 0. It's a function. Okay, and I am checking whether something is available in the serial monitor. Okay, I have a serial monitor here. If some value is coming, right? Some value is coming, then it will be available. Okay, it will be a value greater than 0. This is a function. Okay, this serial dot available എന്ന് പറയുന്ന ഒരു ഫംഗ്ഷൻ ആണ്. It will be taking a value, and if the value is greater than 1, then it says that some value is coming to the serial monitor. If no value is coming to the serial monitor, then the value will be 0. Okay, inside this if loop, I am checking whether some value is coming to the serial monitor. And if it is greater than 0, then I know that some value is coming to the serial monitor. Then I will do the following things. What is inside this bracket? Okay, these things are meant to do if something is coming to the serial monitor. Okay, so I had mentioned a variable called character variable data is equal to serial.read. Serial.read is a function which read the value which is coming to the serial monitor. Okay, I had read the value if it is, for example, I am sending an F. Okay, or I am sending an L. I send an L and I send an L and the serial monitor received the L, and using this command I can store this L to the data variable, this variable called data. This is a user defined variable. I had defined a variable called data, so it's like a storage space. So I am reading this L and storing this L in this location data. ഡേറ്റ എന്ന് പറയുന്ന ഒരു സീരിയൽ ഒരു വേരിയബിൾ ഞാൻ ഡിഫൈൻ ചെയ്തു. വേരിയബിൾ എന്ന് പറഞ്ഞാൽ ഫോർ എക്സാമ്പിൾ യു ക്യാൻ സേ ഇറ്റ്സ് എ ഫോൾഡർ. നമ്മുടെ ഒരു ഫോൾഡർ ക്രിയേറ്റ് ചെയ്ത് ഐ ഹാഡ് ക്രിയേറ്റഡ് എ ഫോൾഡർ ഓർ സ്പേസ്, ഒരു പർട്ടിക്കുലർ സ്പേസ് ക്രിയേറ്റ് ചെയ്തു. ആൻഡ് ഐ നോ ദാറ്റ് സീരിയൽ മോണിറ്റർ ഈസ് റീഡിങ് എൽ, ഇറ്റ് ഈസ് റിസീവിങ് എൽ ആൻഡ് ഇറ്റ് ഈസ് റീഡിങ് എൽ. സോ ഈ റീഡ് കമാൻഡ് വെച്ചിട്ട് ഈ എൽ എന്ന് പറയുന്ന ലെറ്റർ, ആ സീരിയൽ മോണിറ്ററിൽ വന്ന ലെറ്റർ ഞാൻ എടുത്തിട്ട് എന്ത് ചെയ്തു, ഞാൻ ഈ ഡേറ്റ എന്ന് പറയുന്ന വേരിയബിളിനകത്ത് സ്റ്റോർ ചെയ്ത് വെച്ചു. ഓക്കെ, I had taken this L from the serial monitor and stored inside this variable data. Okay, now this is a function for what? For example, there are a lot of functions for using this selection process, but currently I am using this switch data function. Okay, this switch data function is used to verify, like for example, I have a folder and inside that folder I have L, F, R and B. എനിക്ക് ഈ 4 ലെറ്റേഴ്സും ഈ ഫോൾഡറിനകത്തുണ്ട്, and I need to do different things for different letters. Okay, for example, in case of A, for example, I had said that A for forward and B for backward. Okay, A is for forward and B is for backward, and this is a function which define what to do when there is an A, what to do when there is a B, and what to do by default. Okay. So in case A, I am writing digital write 12 high. In case of A, if the data inside this this variable is A, then I have to turn on the 12th pin. If I connect an LED to the 12th pin, then the LED inside the LED connected to the 12th pin will be glowing. And in case of B, then digital write 12 low. If I am sending a B, then the LED will be turned off. So this is the default working of a switch case, and this will be using for our entire program. Okay, നമ്മുടെ സ്മാർട്ട് ഫോൺ കൺട്രോൾ റോബോട്ടിന്റെ പ്രോഗ്രാമിനകത്ത് ബ്ലൂടൂത്തിനെ കൺട്രോൾ ചെയ്യാൻ വേണ്ടി നമ്മൾ യൂസ് ചെയ്യുന്ന ഇതായിരിക്കും. If I am sending an F, okay. Sorry.
So whatever
I'm telling in Malayalam, I will be repeating it in English.
What have you connected?
Where?
12th pin, what have we connected?
12th pin I can connect an LED.
12th pin, what have you connected?
For the verification purpose, you can connect an LED. Okay, you can simply connect an LED along with a resistor to the 12th pin so that you can verify. Okay, after connecting this thing, you can upload this program, and you are sending, for example, using this application I had mentioned, like for this key, for this particular key, it send an A, and for this particular key, send a B. Okay, and I had written this program, and when I press this particular key in my smartphone, the serial monitor will be receiving an A, and it will go to this program, and this program will check that, okay, I had received an A, what should I do? And it will go to the switch case, and in case of A, then I had to write the digital 12th pin to high. Okay, so I received an A, the serial monitor detected an A, it go into the switch case, and inside the switch case, it tested what should I do in case of an A, and it understood that 12th pin should be set high, and it will set the 12th pin to high. So the LED will be glowing. So this is the back end of this entire working, and if in the front end, if I press this particular key, the LED will be glowing. Okay, ഞാൻ ഈ ആപ്ലിക്കേഷൻ എടുത്തിട്ട് ഈ പർട്ടിക്കുലർ കീ പ്രസ് ചെയ്ത് കഴിഞ്ഞാൽ എൻ്റെ 12th പിന്നിൽ കണക്ട് ചെയ്തിരിക്കുന്ന LED blink ചെയ്യും, I mean glow ചെയ്യും. Okay, and if I click on B, it will be turned off. It will be turned on A, and it will be turned off on B. ഇത് എങ്ങനെയാണ് വർക്ക് ചെയ്യുന്നതാണ് ഈ പ്രോഗ്രാം വെച്ച് ഞാൻ എക്സ്പ്ലെയിൻ ചെയ്തത്. How it is we have executed inside this program. Okay.
What is the purpose of the switch data code?
What is the purpose of the switch data? Okay, this is a function in which it decides the purpose of the values inside this data. This data is a variable. Okay, the value which is being sent by this serial monitor A, I mentioned like L, F, B, R, left, right, back, and front. These are the values which is being sent by these keys. Okay, on pressing this key, L will be for example, B will be sent. Pressing this key, F will be sent, like that. Okay, these values will be stored inside this variable data, and now I am switching between these variables. Okay, these letters inside this variable. Okay, that's why I am switching this data variable. So if I write switch data, then the values inside this variable will be analyzed, which are these values L, F, B, or R. Okay, and for example, if I press a forward button, if I press this,
check the value.
Yes, checking the value. If I press the forward button, and F will be sent, and F will be stored inside this data. And in case of switch, for example, if it is F here, then switch the data, it will check, it will like for example search, it will search inside this data variable that is there an F inside this folder. For example, imagine you are searching something in the computer inside a folder. This data is our folder, and I am searching for an F in that folder. If I found that there is an F, in case of an F, then do this thing. In case of for example, in case of back B, in case of B, then do this thing. If there is no F and no B, then just break out of this program. Do nothing. That is just just break out of this program.
Break means nothing.
So that is the simple working.
Break means nothing.
Break means just break out. Don't do anything inside this thing. Just come out of this program. That's it. Okay, come out of this switch case. Inside this is the open brace and close brace of the switch case, and it should be done inside the switch case. Do nothing if the break is being executed. Okay, do nothing inside this program, just come out of the program and execute what is being written here. Okay, so that is the purpose of the break, and that is the default. Okay, if you doesn't have an F, if you doesn't have a B, then break out of the program. Okay, this is just a very simple program used for testing this Bluetooth module. Okay, and the program of the robot will be much more complicated. That's why you had a separate programming session in the last lecture. Hope you had followed that lecture. And I came out of the program and I had written serial.print data. Okay, what this will be doing is that inside the serial modular, it will be printing what data is being received. Okay, from the smartphone, it is sending a data to the Bluetooth module, and the Bluetooth module is sending a data to the Arduino board, and the Arduino board will be sending the data to the serial monitor, and we will be able to see what data is being sent. If I press the up arrow, an F will be shown in the serial monitor. If I press the down arrow, a B will be shown in the serial monitor. Okay, it is for our like convenience. We can see that okay, F is coming, and if the robot is not working properly, then we can understand that if F is there, but the program is not working properly. That's why the robot is not working properly. Or it might be some physical problems also. Yes, we are running out of time. We had few more slides to complete, so I'll be moving to the next slides. So yeah, this is not necessary for you guys. This is the connection diagram. Okay, if you are building a robot, this is the connection diagram for the motor testing. You can connect the motors like this. Okay, I had already mentioned the connections here. One will be connected to this port, another will be connected to this port, second motor will be connected like this, and we have motors in 1, in 2, in 3, and in 4. Then this is for the 12 volt and the ground, and there will be a 5 volt and a ground. Okay, these were the connections of the L293D motor driver IC. These are the connections, and you can upload this program. I will be providing these programs also. You can just directly upload these programs for testing the motor. Okay, and in here I had mentioned like these are the variables, like 4th pin is for motor 1, 5th pin is for motor 1. Motor 1's first connection, 4th pin, motor 1 second connection. Can
you make it big?
Okay, let me try.
Take new zoom.
Is it visible now?
Yes, sir.
Yes, sir. Analog pin you have used.
Analog pin you have used.
Where?
A1.
A1.
No. This is just a variable. Okay, this is int. Int means integer, and this is a name of the variable. It's not A1 analog pins. Because we have only A1, A2 analog pins. B1 are not analog pins. So this is just a variable, name of the variable. So I had named the first motor as A. Okay, so consider the first motor as A, and the first pin, first wire of the motor, that is A1. A1 is connected to the 4th pin of this Arduino, and A2 is connected, that is the second wire of this coming from the L293D module will be connected to the 5th pin of the Arduino. So this is for the second motor. Okay, just you can directly mention the 4, 5, 6, 7 for the convenience. I had mentioned like A1, A2, B1, B2 because while programming it will be easy, because normally we have like pin mode 4 output, pin mode 5 output, but I had mentioned like this is A1, this is A2, this is B1, this is B2. 4 is A1, 5 is A2, 6 is B1, 7 is B2. So now I need to mention like A1 output, A2 output. Instead of mentioning 4, 5, 6, and 7, I can mention like A1, A2, B1, B2 like that. Okay. This is just for our convenience. And these are separate functions. Okay. Front, stop, back, stop, right, stop, left, stop. Okay. These are just functions. So if this function is executed, the robot will be moving forward, wait for 1 second. Then it will stop, wait for 1 second, then it will move backward for 1 second, then stop, then wait for 1 second, then move right for 1 second and stop, wait for 1 second, like that. And what these functions will be doing will be written outside this loop. Inside the loop, I had this is just a test program. If I upload this test program to the robot, then the robot will move forward, move backward, then right, then left. Okay, it will be continuing. And what the write will be doing is that digital write A1 low, A2 high. This is, for example, what one connection of the motor is set to high and another connection is motor is set to low. Then it will be rotating in one direction, and same connection of the other motor is set to high and the other connection of the motor is set to low. It will be rotating in the same direction. Then it will move forward. Okay, low high means the motor will both the motor will move forward. And if I reverse direction, okay, high low means both the motors will be moving in reverse direction. Now see here, in order to move right, one motor will be moving in forward direction, another motor will be moving in the reverse direction. It will be rotating. Okay, rotating in the direction that is low high low. Okay,
So
A1
which we
A2,
will find
A1
by
is low,
trial.
A2 is high, B1 is high.
So which we will find by trial.
Yeah, you can find it by trial and error method, or you can directly, like, you can remember, like, I had connected the first motor's first pin to A1, first second motor's second pin to like first motor's second pin to A2, like that. Okay, and you can do it by trial and error. Like if it is rotating in the another direction, you can just directly change the low high direction. Okay, if I put low high and the motor is driving in the forward direction, then just reverse the direction, like instead of low high, put high low, then the motor will be driving in the opposite direction. Okay, simple. That you can do while practicing. You'll get to know. Okay, so, and for left, in the opposite of this right, low high low for the right, then high low high for the left. And for stop, all the pins should be low. No voltage should be sent to any pins, then the motor will not be moving. That is for stop. So these are the functions. These are the functions which I had written, and these functions are called inside the loop. Okay, these are the programming part. I will not be stressing much in the programming part because you already had a dedicated session for the programming. Okay, now this is the entire connection diagram of our smartphone controlled robot. This is the entire connection diagram. We have the L293D module here, 4 pins. For this is A1, this is A2, this is B1, this is B2. Okay, it is connected to the
zoom.
Yeah, little bit. Why is it not showing? Okay, I don't know why, but it's not showing. Yeah, is it visible now?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
So this is the first connection, and it is connected to 7th pin. This is the second connection, that is like this can be A1, this can be A2, this can be B1, and this can be B2. A1 is connected to 7th pin, A2 is connected to 6th pin, B1 is connected to the 5th pin, and B2 is connected to the 4th pin. Now you can program using these pins. Okay, 4, 5, 6, and 7. And the VCC is connected. See, I had used a breadboard. I had connected the 5 volt to this row. So this entire row will be 5 volt, and this entire row will be ground. Okay, now it will be convenient for me to do all these connections. So 5 volt will be connected to here, and the ground will be connected to here. Instead of connecting to the Arduino board, I can connect to this thing. Okay, now I had used a 9 volt battery. In order to increase the power, I had used a 9 volt battery in parallel. So the voltage will be same, but a little bit more current can be used for driving much more power. And the motors are connected. So
9
this
volt
is
battery.
the 12 volt and ground pin, 12 volt.
9 volt battery.
Yeah, 9 volt battery.
Why?
I didn't get why.
Why? I had already mentioned, right? In order to power this motors, you need an extra battery, which the 12 volt pin will be connected to that battery, right? Do you remember?
12 volt will be to these two.
While
12 volt will be to these two.
explaining this 12 volt will be connected to an external battery I had mentioned.
Yes, sir. Yes, sir.
That external battery is this thing.
Yes, sir.
Yeah.
Got it.
Yeah. Not here. Here. Yes. And even though this is a 12 volt port, you can connect 9 volt and it will be more than enough for driving this motors. Okay. And one 9 volt battery will be enough, but there will not be much power. Okay. In order to draw much more power, I had connected an extra 9 volt battery in parallel. Parallel connection will enable like 9 volt. But if this one was 1 ampere, then it will be like 2 ampere or something like that. Parallel connection will improve the current capacity. Okay, and okay, this don't bother about this thing because you will be connecting this to the computer, then it will be powering from here. And if you are doing a dedicated robot, for example, this thing is a dedicated robot, so it doesn't we cannot connect the wire always with the computer. So for that we can use an external battery for powering up this Arduino board. Okay, for that I had used a battery and I had connected it to the V-in, which I had mentioned in the first lecture. The V-in here, V-in can be connected to an external battery. It will be serving the same purpose as this power input socket. And what else? We had connected the HC05 Bluetooth module. The 5 volt VCC is connected to the 5 volt and ground is connected to the ground. And the other TX and RX are connected to the RX and TX of the Arduino module. So this is the entire connection diagram of the smartphone controlled robot, and we have a program here. If you upload this program, if you take your smartphone, do the connections as mentioned in this connection diagram, then done this program, upload this program to the Arduino board, and use your smartphone to control the robot. The robot will be moving. Okay. And this is a combination of all the programs which I had already mentioned. Okay, I had used an extra thing called software serial 1011. We have a default RX and TX in this thing, right? We have a default RX and TX in the Arduino board, but you can use any other pins for TX and RX. For example, 10 and 11 can be used for in the purpose of TX and RX. For that, you have to write an extra code. Okay. Normally, TX and RX are 0 and 1 ആണ്. But instead of using 0 and 1, I can use 10 and 11. Some other pins, but I had to mention, okay, these are the TX and RX pins. For that, I can use software serial BT module 10,11. So this will mention that this is the RX, 10 is the RX, and this 11 is the TX. So instead of connecting to the 0 and 1, I can connect the Bluetooth module TX and RX to 10 and 11. Okay. Then I had mentioned A1 is equal to 7, A2 is equal to 6, B1 is equal to 5, B2 is equal to 4. Then set pin mode A1, A2, B1, B2 as output pins, and serial.big 9600. It will yeah. Serial.big 9600. It will enable the serial communication between the Arduino board and the computer, and BT module.big 9600. This will enable the communication between the Bluetooth module and the Arduino board. Okay, BT module.big 9600 will enable serial communication between Bluetooth module and the Arduino board. Okay.
So BT module
Now,
is black color.
BT module is black color. It should be colorful.
No, because BT module is the name of a function which I had mentioned. I had written. Okay, you can write any name. You can write like, for example, you can write like Bluetooth in brackets 10,11, or you can write your name. Any name can be written here because it's.
If you are using normal.
If you are using normal.
RxTX, then
using normal, you doesn't need to write this entire line. Software serial BT, but there is a problem. Okay, there is a problem. If I mention, then it will be much more complicated, but yeah, I will try to mention. because this serial this serial communication between this computer and the Arduino board will be happening through this pins 0 and 1, the default TX and RX. Okay. And if you are using this Bluetooth module also, if you connect the Bluetooth module serial communication also to this TX and RX, then this will not work. അതായത് ഈ ഓർഡിനോ ബോർഡിൽ TX and RX പിന്ന് സീരിയൽ കമ്മ്യൂണിക്കേഷൻ ഓർഡിനോ ബോർഡ് യൂസ് ചെയ്യുന്ന 0 and 1 തന്നെയാണ് നമ്മൾ ബ്ലൂടൂത്ത് മൊഡ്യൂളിനും വേണ്ടി ഉപയോഗിക്കുന്നതെങ്കിൽ ഇത് രണ്ടുകൂടെ പാരലൽ ആയിട്ട് വർക്ക് ചെയ്യത്തില്ല. Either of the one will be working at a time. Okay, if you're using both of them, then the serial communication between the Bluetooth and Arduino board will not be working. Otherwise, the serial communication between the computer and the Arduino board will not be working. So for that, in order to use both the things parallelly, I am using this thing. So for this serial communication, it will be defaultly using this 0 and 1. And for our communication for the Bluetooth, I will be using 10 and 11. So there will not be any confusions. Okay. You can use this thing also, but you will face some issues. Okay. So I am checking like Bluetooth.available if any value is coming from the Bluetooth module. Instead of checking the serial monitor, I can directly check on the Bluetooth module itself. Okay. Whatever coming in the Bluetooth module will be coming in the serial monitor also, but I can directly check on the serial this Bluetooth module itself. Okay. If Bluetooth.available greater than 0 means something is coming in the Bluetooth module, then I am saving that value in the data variable, and I am switching this data. If forward, if F is coming, then friend. I am calling the function friend break. Okay, after executing this friend, get out of the program. Okay, then again check if another value is coming like that. Okay, if back is coming, do the back and break. Then come out of the program, check again any other value is coming. Okay, like that. For R, write, yes, stop, and default. If nothing is coming, then it will be in the default position. Okay, default mode. Nothing will be executed inside this program.
After this,
okay?
why are we telling serial.print?
Why are we telling serial.print?
Yeah, I'll explain. Don't get panicked. Okay, so serial.println data means for us to understand if any data is coming. Bluetooth will be knowing, okay, this data is coming, but we doesn't know what data is being coming into the Bluetooth module. For us to understand what data is being coming to the serial Bluetooth module, we will be using the serial.println. So inside the serial monitor, we can see what all data is coming to this data variable. Okay, serial.println data. Okay,
then
so that is the purpose of this monitor. So we will understand.
Monitor.
Yeah, we can see in this computer monitor, serial monitor, that this value, this F is coming, this B is coming, L is coming, R is coming, S is coming. If some other value, some gen value is coming, also coming, we can see, okay, this gen value is coming to the data. But if only for these cases, it will work. This function will work. For all other cases, if you're sending some random data, it will not work. That is the default break. Okay. And delay 50, that is just a intentional delay for the proper working of this in the modules. Okay, if you doesn't put any delay, then it should be continuously reading, and the process will not be like reliable. And these are the things which I had already written, the functions for the right, left, front, and back, stop. That's it. This is the entire program. If you upload this program
After the loop or before the
outside the loop. So this is inside the setup, this is inside the loop, and outside the loop you will be writing the functions. Okay, what the functions should be doing, it should be written outside the loop. What?
Which void first doesn't matter.
I didn't get
void first doesn't matter.
No, I didn't get you. Void.
First void setup, then void loop, then right
setup,
void right left like that.
Void right
Yeah.
left like that.
Yeah, this void setup is a function, that is a setup function, and void loop is a loop function, and these are the other function, external functions which we are writing. Okay, I am writing a function called right, I am writing a function called left, I am writing a function called front, back, stop. Okay, these functions are called here front, back, left,
So
right,
that
stop.
I understood. I am asking is
This
about
is
the order.
Yeah,
I'm asking is about the order.
any order
After
is
void
possible.
loop
Okay, you can write in
function,
any
yeah.
order, but
After void loop function,
yeah, after void loop you can write in between also. It's not an issue. Okay, void setup will be executed, then these functions will be these function will be stored, and then you can write the loop, and then you can call this thing. Or else normally we, as a convention, every program is written according to convention, and according to the convention we will write after the loop. After writing the entire loop, we will be writing what all functions are used inside this thing and the cases for each of the functions. Okay, so that's it with the programming part. And after doing all those things, you can build a robot like this and you can control using a smartphone, and this will be the working. This is how it will be moving forward, left, right, like that.
So LED is extra, right?
LED is extra, right?
LED is extra. That is according to your convenience. You can put LED, you can remove LED, you can put a fan, anything is possible. After playing around with the basics, you can add your own additions. That's fine. So this will be the kit which you will be getting. See, you can see a motor here, gear DC motor, the batteries, 2 batteries, and you can use a battery for the Arduino board right here. And what else? The L293D driver is here, right here. The 2 LEDs, the 2 red LEDs are from the L293 module. And then we have a caster wheel here that can rotate in any directions. Yes.
Front wheel.
So I think that's front wheel. Yeah, front wheel. That's called a caster wheel. It can rotate in any directions. So this is how the robot will be working. So this is the practical system, and thank you. And you can connect with me in LinkedIn, and you can send me messages in WhatsApp. I'll try to answer your questions according to my schedule. Yeah. So if you have any doubts now, you can ask, but the time is already up. So if you have any doubts, you can ask. I'll try to answer quickly.
What is the app you are using?
Sir, instead of serial, we can use some other thing.
Instead of what?
Serial.
Serial.
Instead of serial? I didn't get the question.
Can we use some other codes? Instead of serial.
Instead of serial, can we use some other code? What do you mean? Like, serial is not a code. Instead of the software serial function, are you asking about the function?
Yes, sir.
Yes or no?
Yes, sir. Serial. What is the use of serial there?
Okay, there is nothing called serial here. I have a software serial here. This is a function. Software serial.h is it's a library. It's called a library which enables to change the enables to add a particular RX and TX. Okay, this 10th and 11th pin can be set as a transmitter and receiver pins. This library is doing that function. That's why I had included this function, this library here.
You have to do that first.
Yeah, you have to include this thing. This library should be included for working this thing. So this thing will only work if I had included this library. #include software serial.h. Was that your question?
Sir, can we use other libraries also?
Yeah, you can use. There are multiple libraries. You can use other libraries also. You have also other libraries for changing this TX and RX. You can use any libraries. It's possible. Any other questions?
What is the app you are using in smartphone?
Yeah, it's called Arduino Bluetooth. You can just simply search on the Play Store. I'll just see whether the app is still available. It was during my college days. I'll search for Bluetooth control. Yes, it's still available here. There are lots of applications. You can use this thing, Arduino Bluetooth, something called like this, Arduino Bluetooth control, or Bluetooth.
Sir, all three PPTs you will get, right?
For all three PPTs you will get, right?
Yeah. And this was the application which I am using, Ordinal Bluetooth. You can just simply search on Ordinal Bluetooth and you will get multiple applications. And any other doubts? This is just for the demonstration. You need not to do this project. You will be given some constraints like set of project list, and you have to do from that list, or else you can come up with some more innovative ideas and you can do that project. This is just an introduction, just a demo, how you can use the knowledge you had already studied to build a project. That's it.
Okay, sir.
And I'll introduce one platform also, and like if you doesn't have the equipments, but you need to
Tinkercad.
Tinkercad.
Yeah.
So that last class we did it that way. Demonstration.
Last class we did it that way.
Oh, you done the demonstration in Tinkercad only, yes. Then it will be easy for you. You can do the HCC Rafa Bluetooth module will be available there. Everything will be available there. You can just do this. Here's something. And do the programming. Are you familiar with the block coding and all? It here explain how to code, how to do the coding without knowing the coding.
App making step.
Anyone?
App making step.
Sorry. Yeah, this is something, the similar circuit which I had created for the demo purpose. And Tinkercad. You can use this platform to create the circuit which I had already given to you, and you can do the programming and you can see how it's working. I haven't opened it for some time, so it's taking some time. Meanwhile, do you have any other doubts? This is L293. It doesn't have a module. Okay, keep in mind that it doesn't have a module in this thing, Tinkercad. So you have to insert the driver IC and do the connections manually. Okay. And the connections will be mentioned here. Output ones. You can see when you put here input 1, input 2, output 1, like that mentioned. You can directly do the connections. And in the code section, you can upload the code here. Okay, and if you click on start simulation, you can see the motors will be rotating. See, it will be rotated. This one is rotating in 244 RPM. This one is not rotating. And if I change the high low right here, the other one will be rotating like that. Okay, for example, this is low high, this is low low. Okay, if I put this is also low high. Do you have time? I actually doesn't have much time. I'll just show this thing and stop. I put this also high and this also high. Then if I start simulation, then you can, yeah, one second, something went wrong. Motor pin 1 high, motor pin 2 high low, 1 low. Okay, sorry, this should be high. Try GH high. Low. Yeah, let's see. For 1 second, this will be rotating, and later the other will be rotating like that. You can test the code here, write the code here, and you can see the rotations here. Okay. And you
Sir,
can also
Tinkercad,
do
you are telling.
but I don't.
Sir, in Tinkercad, you are telling
Bluetooth module is not there.
Bluetooth module is not there.
Bluetooth module, I don't know. You have to check whether Bluetooth module is there.
So without that also we can do.
I had told that
Without that also we can do.
Without Bluetooth module, you cannot do this program, but you can test other programs. I am not asking you to do the program which I had mentioned in this in the session. You can that was just a demo. You need not to do that thing. You can do other projects. And I'll check whether Bluetooth module is available or not.
So this code is for what project?
So this code is for what project?
This code is just for the demo, just for showing the working. I don't know when I created this thing for some other sessions or something. Bluetooth. This is just for the testing, whether the motors are working properly or something. Yeah, I think Bluetooth module is not there. Let's see, 05. See, 05. HC05 is not there. HC06. HC quant and hex converters. Yeah, you can use other modules also. These things will also work, okay? Because our yeah, this will not work. This will not work. These are switches. So Bluetooth module is not available in ThinkerCAD. Sorry. HC05 is not available. You can do other projects because ThinkerCAD is just for the basic understanding of this working of the simulations and all. So everything will not be available. And if you need to do such hardcore simulations, you can go for like Simulink or some other simulation softwares, which are much more complicated. It will not be as easy as ThinkerCAD, but you can study there also. Any more questions?
No,
Any more questions?
No,
Okay,
sir.
I think we can.
ThinkerCAD project you showed that not clear, but
Project you showed that.
smartphone control is okay.
Yeah, that's not for you. I was just introducing you to the ThinkerCAD. Yeah, this ThinkerCAD project is not for you. Just for the testing purpose and all. I have created that project. That's not for you. You can use the ThinkerCAD platform to create your own projects. That's what I was meant to mention. Anything else?
No, sir.
No, sir.
No, sir.
Okay.
No, sir.
Okay, I think Bhagya, we can wind up.
Thank you, sir. Have a nice day ahead. Thank you, sir.
Thank you.
Have a nice day ahead.
Bye, sir. Have a nice day.
Hello.
Bye, sir. Have a nice day.
Thank you, sir. Have a nice day, sir. Hello. Thank you, sir. Have a marvelous day. Thank you, sir. Have a marvelous day.
Okay, thank you, sir, for your wonderful session. As we are
Okay,
about
thank you, sir, for your wonderful session.
as we are about to mention that right before we wind up, we wish to take a digital photograph towards the all the participants, please be ready for that so that we can keep it as also we have provided a feedback form in the chat box. I request all the participants let me welcome Nita of MEA Engineering College for
Hello, am I audible?
Yes, Nita, you are audible.
Okay. A warm and graceful evening to all. Myself, Nida, Program Committee Coordinator at IEEE PES MES BC. It's my privilege to propose the vote of thanks and acknowledge the contribution of those who work really hard to make this event successful. On behalf of STEM Ed conducted by IEEE PES Kerala chapter, I extend my sincere gratitude to our resource person, Engineer Anish M S, Global Relations Coordinator at IEEE PES YP Kerala, who spared time from his busy schedule to grace the occasion. The section was indeed insightful and it will surely encourage the students in the upcoming phase of events. I am immensely thankful to you, sir, for sharing your knowledge in such elegant manner. I wish to mention a deep sense of appreciation. I also extend thanks to the all coordinates and the participants for your enormous cooperation within this event. Thank you all.
Now I request you all to turn on your camera for a virtual photograph. Bhagya, is it okay?
Yes. Can you tell after the screenshot?
Thank you.
Okay, Fatima, now we
Okay,
can
thank
continue.
you. I would like to thank all the teachers and the students for joining us today for this session. We hope all found this session to be an interesting and insightful. Thank you, everyone. Thank you. Have a nice day ahead of you.
Feedback form is not there yet.
Thank you. Bye.
Just one second. I'll